Hello guys, welcome to our physics lab experiment series. In this video, let us learn about LCR series experiment. So this is Anil.
And this is Adith.
We are E-batch student of 7th semester. So now we will learn what is LCR series experiment, what are the used apparatus, theory, means how can we perform the experiment. First of all, let us see the aim of this experiment. In this, we will study the frequency response of series LCR circuit. Second, we will try to measure the resonance frequency and quality factor. So to do this experiment, required apparatus are
Inductor. An inductor is a passive component that is used in most power electronic circuits to store energy in the form of magnetic fields when electricity is applied to it. One of the key properties of an inductor is that it impedes or opposes any change in the current flowing through it. The second component is capacitor. A capacitor is a device for storing energy in the form of electric fields and consists of two conductors in close proximity and are insulated from each other. The other one is resistor, voltmeter, function generator. Function generator supplies alternating voltage supply that is tunable. And then we'll need connecting wires. The theory of the experiment. First, we need to know what is resonance. Now, as we tune the frequency of the alternating voltage source, the response of the RLC series circuit will vary. And for one particular frequency, the response of the circuit will be maximum. This phenomenon is called resonance. The resonance or natural frequency of a series RLC circuit is a frequency for which the response of the series RLC circuit is maximum. And this maximum frequency is called the natural frequency of that RLC circuit. The condition at which this resonance occurs is when the capacitive reactance, that is, the resistance provided by the capacitor, is equal to the inductive reactance, the resistance provided by the inductor. When this happens, the total impedance of the circuit is at a minimum and is purely resistive. The resistance throughout the circuit will only be due to the resistor. Now, what is meant by gain? The ratio of output voltage across the resistor to the input voltage that we are applying through the alternating voltage supply is called the gain. What is cutoff frequencies? Now, these cutoff frequencies are also called as half power frequencies, and these are the frequencies at which the gain of the series RLC circuit is 1 by root 2 times the maximum gain. The bandwidth of the series RLC circuit is the difference between the cutoff frequencies. Ideally, we would want a smaller bandwidth, and quality factor is given by the resonance frequency divided by bandwidth. Now, quality factor defines the selectivity of the series RLC circuit. The series RLC circuit is used in radio communication. So, if the quality factor of a particular circuit is high, then we can easily select a channel and other channels will not interfere with the channel we are listening to.
Now we have learned theory of the experiment. Before going to the procedure of the experiment, let us go to the circuit diagram. And in circuit diagram, if we see, there are three main things. They are L, inductor, C, capacitor, and R, resistance. And if you see, the parallel to the R resistance, one voltmeter is connected, and second to the parallel to the source is one more voltmeter is connected. So now we have seen the circuit diagram. Now let's go to the procedure part of this experiment. So in procedure, first of all, we need to make the connection of the circuit giving to the circuit diagram.
Now to connect the circuit, the required apparatus are inductor, capacitor, resistance, multimeter and current source.
According to the circuit diagram, we will take a wire and one side we will connect to the inductor and second side we will connect to the capacitor. Now we will take another wire and that we will connect to the capacitor one side and another side to the resistance. Same thing we will do, and we will take a wire and again we will connect it to the resistance second side, and using another side of the wire we will connect with the source, current source. Now to the current source second side we will take and we will connect to the remaining one side of that inductor. Now we need to do one more thing, that is we need to connect the multimeter parallel to the resistance, and one more multimeter we will use to connect the parallel to the current source. Now our connection is ready. L is connected to C and C is connected to R in series. Means inductor is connected to capacitor, capacitor is connected to resistance, and resistance is connected to current source. Now to perform the experiment we need to do two things. There are two multimeter and both are showing us two voltage. Now what we will do, we will change the input voltage in a voltmeter and see the output voltage, and using that we will note down the reading in a tabular column. Now to perform on the experiment we need to keep the capacitance value such that the natural frequency of circuit it should be more than 1000 Hz or 1 kHz. After keeping the natural frequency, we will find the output voltage by varying the input voltage. That means we will vary the input voltage which we are giving, and output voltage we will observe. So using that one we will write it in a tabular column. We will note down those reading. After the taking the reading, now we have taken the reading. So according to given that input voltage we are getting output voltage. Using that one we will see our experiment. Now if you see the tabular column, I have taken some random values. So with the help of input voltage and output voltage we can calculate the gain, the value of XL, XC. So I have calculated this one if you see the tabular column. Now by using this data we will draw two graphs. One graph is resistance versus frequency. Second one is gain versus frequency. And like this, with the help of graph we can find the result like resonance frequency, quality factor, bandwidth,